So again, I'm Ricard Gavalda. I'm very glad to have the opportunity to present you something that we've been working on for the last 7 or 8 years. It has the name Amalfi Analytics. That's the name of a startup. And as you see from the title of the talk, we basically do machine learning for the healthcare system. Not for healthcare, not for any kind of healthcare problems, but for what we call clinical management problems. And from what you see in the subtitle, the emphasis of my talk is going to be on decisions that we have made in bringing research to the actual hospitals, and in particularly my focus, you're going to see, the focus of these decisions are mostly scalability. I'm afraid the talk is going to be a little bit EU-centric. In the EU, most of a large part of the healthcare is publicly funded, but I promise you that the issues at the bottom are basically the same also for private healthcare and for other countries as well. The economic incentives are different, but the issues are the same. So here's what I'm going to tell you. I'm going to tell you the kind of problems that we wanted to address. They all stem from one big, huge problem of which we don't talk enough in healthcare. I'll tell you who we are, what is Amalfi Analytics, and our approach, which is probably not the first time that has been tested, but it's not as widespread in the EU, and why I think it's a good approach. I'll tell you what we have done up to now, which is 2 different platforms powered by machine learning. One more on the predictive side, if you want supervised machine learning, and the other one on the knowledge discovery one, so more unsupervised learning. And then I'll talk about also these decisions that we've made and how we have approached the development of these platforms to make what we do practical and, as I say, scalable. Okay. So what is this big problem that we face? It's like climate change. We've known there's this huge problem coming to us for a long while, and still somehow we keep doing business as usual. We do talk about them, certainly in the healthcare circles, but a little bit in, even the popular press. It's called the silver tsunami. Silver because of the color of these graying hairs that I'm beginning to grow, and tsunami because it really threatens the survivability of the healthcare system as we know right now. It's one of the pillars of the welfare state, and my goal when going into all this is to try to keep healthcare accessible for everybody and universal, if you want. Okay, what's this silver tsunami? It's aging, basically. Today, about 22–24% of the Europeans are above 65. That's going to almost double by 2040. And, aging and the chronic disease that it brings about is already taking 70% of the expense in healthcare. So somehow the system keeps us alive for longer. We don't die anymore at 50, we die at 85, 90, but we require a lot of money, a lot of resources to do that. So it's clear that we are in a collision course if we keep the same resources, but it's unlikely that we're going to get many more resources because healthcare in the developed countries across the world is already taking about 10% of the GDP, and in the EU in particular is taking about 20% of the public expense. So even if there was the political will to fund healthcare more, it's going to be difficult because aging also means more money for pensions, more money for social care, and few people contributing to the, sustaining the system. So we need to be able to do more with the same resources or less if we want to keep healthcare as we know it existing. So how can we do more with less. I've gone over the initiatives that work in this direction, and they basically go into two categories. One is try to reduce the burden of low-value, repetitive tasks that typically can be automatized. And here we have telemedicine, where you can use economy of scale and have fewer people specializing in a few more things, having chatbots recording the sessions between patient and doctor and putting the information in the clinical histories, or chatbots also for the first line of assistance to people that call, etc. That's definitely something that has to be done. The other line, the line that we take, is attacking the waste, the inefficiencies, the redundancy that exist in healthcare system. And I tell you, they are like huge ways, huge things that are potentially improvable in healthcare. And what we want to do, like many other people, is use the data that the system already uses and collects to detect these inefficiencies and try to solve them, okay? Who are the people that want to do that? So I'm Ricard. I used to be a professor at the Technical University here in Barcelona, the other end of town, but still Barcelona. I used to work on machine learning, especially data stream mining for the last period of my academic life. I was sure I was going to retire as an academic, so that my job, which I liked, was to teach, to read papers, to write papers, to supervise a student. I was happy with that, but life had other plans for me. These plans arrived in the form of Dr. Juliana Rivera. She is a doctor, force of nature, and she has had a career of over 30 years in management positions in the area of Barcelona mostly, but organizing processes in hospitals, setting up clinical documentation systems, in primary care, organizing the resources and the protocols for the people that come again and again, at the regional government level, making plans for how to distribute resources in a region that has about 8 million people, etc. And she started telling, when I met her, she started telling me, look, Ricard, we need to manage a very complex system, and we're still doing it. She uses very passionate words, which I'm not going to repeat here, but we're basically managing, still only doing subtraction and percentages. This cannot be. You guys in computer science have better tools. Let's do it. So basically, what we're trying to build is the tools that she, as a manager, wanted to have and did not find in the market. We created Amalfi Analytics as a spin-off of the university in 2017. We didn't know what we were getting into. We had no experience at all in entrepreneurship or in selling, etc. But this talk is not about the joys and sorrows of being an entrepreneurship. And it was a side job for a while, a side project for a while. At the end of 2019, we get an investment so we can start hiring people and actually building the products. I took a leave of absence from university in March 2020, literally 1 week before we were locked down for COVID, which meant stopped talking to hospitals, even the hospital we were talking to. Those were tough times, and it was kind of 2 years in a commercial desert because the system was in survival mode, and then after that it was just trying to recover from a state of shock and depression. In the meanwhile, thanks to supportive investors and luck, we were able to create a fantastic team of technical people. People come and go. It's 5 people right now, and to build product. So where we are now is, as of today, we are present, or we have tested our platforms in about 25 hospitals, mostly in Spain, with some tests in France also. And an important, so we are good. I mean, this is much more than what many other startups in health have achieved. an important change is that in December 2023, so about 9 months ago, we were fully acquired by a group called Allianz. They are based in France, but also have offices in Spain, Italy, Germany, and they operate in many other European countries. Their core business is actually, the original business is actually insurance, but very special kind of insurance. They insure hospitals for civil responsibility, so for medical practice, medical malpractice claims, for accidents, for medical errors, etc. So you can bet their goal is to make their hospitals safer places so that there are less claims and less accidents, okay? At some point, they decided that one way of doing that is adding technology to the hospitals. So now the technology branch is getting more and more important, and they bet on our products as a way of reducing risks for their hospitals. Hospitals are very dangerous places. Try to avoid going there unless it's really necessary, and we'll see. But you will see that our initial mission, which was about efficiency, etc., also now has the subtitle "and avoiding risks for patients." Interestingly, rationalizing resources, rationalizing the use of resources, and making hospitals safer, which might look as contradictory goals, are actually very correlated most of the times. Okay, so what is the way we chose? There is all these initiatives that make the headlines in healthcare and artificial intelligence about personal medicine and adding the omics and super patient-by-patient diagnostics, etc. That is good, but that is costly and it's going to take a long time. And it's not clear that immediately impacts in the resource usage of the healthcare system. Don't get me wrong, we have to work on that, and we want to have all that by 2040, 2050, we have to start right now. But what we chose is, let's try to address the biggest money leaks in the healthcare system, and for that, the idea is try to use humble, shallow, even sometimes mistaken administrative healthcare data, which every hospital has, and I'll show you an example of what I mean by that, plus the proper machine learning algorithms to get efficiency, savings, which can be put to other users, to get quality of care, that is better results for the patient, to reduce risks, make hospitals safer places, and for scalability. And as I say, scalability will show. We made choices about which problems we address based on the data that we know we're going to get mostly everywhere, okay? Also, the problems that we address, you will see, have far lower, generate far lower ethical and legal and even regulatory concerns than if you try to do diagnosis and the recommendation for every specific patient, okay? What do I mean when I say administrative data that every hospital has? There is this kind of international standard. It's not like super rigorous standard. There are dialects in most countries and there are changes. It's called the minimum basic data set. It is promoted by the World Health Organization. And it's basically used for billing. So at least all private, publicly funded healthcare in Europe has to report this minimum basic data set to their payers, the government, typically. It looks like this. Why say? Imagine like a spreadsheet. Every column is what we call an encounter of a contact of a patient with a visit, and the columns have different meanings. It basically says, patient number, blah, blah, blah. This, in reality, this may have your name or your passport number or something like this. We always get it anonymized, so because the identity of the person, we're not concerned. who has this sex and was born on this date. Maybe we only get the year because for additional property, who lives more or less here, and that's what you may vary from one data set to another, arrived on this date, was discharged on this date, arrived by ambulance or by their own means, or the police brought this person and it came from home or it came from other hospital. This is like how different dialects vary a little bit. And the status at the discharge was the person was sent home or was sent to an elderly home for the elderly, or died or escaped. This happens sometimes, okay? And then the key part, besides the dates, is the list of diagnostics that this person received in the hospital, for example, and the list of procedures. For the procedures, I only put a couple, the number of, and these are coded. The codes that you see there for diagnostics and procedures are from a code called ICD-10. There are like 70,000 different diagnostics in ICD-10. Some are very infrequent, some are frequent. One of the diagnostics is marked as primary, and one of the procedures is marked as primary, like what is considered most important that the person had or did not have. Okay. So, for example, I remember E11.91 is one form of complicated diabetes. You see, this data cannot, and one of them is hypertension, I think some other is hypertension. This data does not contain what the level of sugar in blood for this person was. It does not contain what the actual measurement in their hypertension was. So it is really not possible to do any kind of personalized diagnostics with this. We tried, but or even predict something like, is this person going to die or is this person going to need a bed? You don't get enough precision with such shallow data, but you can make collective predictions based on this data. Somehow the predictions that if you manage to balance the biases in one way or the other, you can answer questions like, how many people are going to come tomorrow to my emergency room, how many will need an operation, how many will need surgery, how many will need a bed, and how long are, on average, they're going to stay, okay? Every hospital in the countries of the EU that I know creates files like this and sends them, as I say, to the government regularly. And that is a good thing for us, because it means that the quality is relatively decent, that every hospital has made the effort to extract, to build the database query to extract this kind of thing, this kind of data from their systems, okay? And actually what happens right now, we go to a hospital, we say, we need this data. How do you get it? You know this query that you throw to your database once every month for your government? Yes. Now, instead of that, you run it every 15 minutes or every hour. It's going to depend on the application, and you send that through our API so that we know what your recent activity is. For billing, actually, I want to throw in a name that will show up. The government pays the hospital essentially by the activity reported here. So I'm going to pay you that much for someone that has a heart attack, or for someone that has a child delivery, or for someone that comes with a kidney problem, etc. That is slightly modulated by the complexity of the procedure done and other diagnostics with aggregators. DRGs are called diagnostic related groups, are one of those that are mostly used in Europe. I mentioned the name because it's going to show up later. And basically it puts every patient in one box that determines how much money the government is going to pay for that. Because of that, our aim is to work at various levels of the healthcare system. At the micro level, imagine a service like the emergency service or the cardiology service or the traumatology service of a hospital, whose main responsibility is to provide quality and safety for their patients. At the meso level, imagine the management of a whole hospital that needs to partition the resources among the different services, and also to the macro level, people that plan for a whole country or for a region or for an area, etc., whose main concern is to distribute the resources to make prevention plans so that healthcare is accessible and fair for everybody. We have created two platforms. The first one is for hospitals mostly, and it addresses the micro and meso level. And the other one is an analytical platform that has users in the three levels. So basically, the predictive platform is a support for operational decision-making in hospitals. It's for like fast decisions, what's going to happen today, should they change things next week, maybe next month, okay? The analytical platform is more for sitting down, discovering how my population is, and trying to rearrange things with more study, often, regarding population health. Okay, the predictive platform for hospitals. Basically, we try to predict activity, the resources that you're going to need at various parts of the hospital, and the resources that you're going to have available. The goal is to let the people with managing responsibilities anticipate, rather than reacting all the time to stuff that happens, okay? Which is what they are doing right now to all the time. And that's, I mean, it's not easy to run a hospital. It's a very complex organization, and you tweak something in this part and it affects this other part, etc. Okay? Let me show you crash course on the main parts of a hospital, in case you didn't know. What are the main patient flows? So many people arrive to the hospital through the emergency department. Between 40 and 60% is typical in most hospitals, okay? The labels in red are things that we are predicting based on past activity. So we predict the number of arrivals, typically classified by severity, how many people will require immediate or very urgent attention, and how many people can wait, okay? We predict box occupation. This we only do for the next 24 hours. It doesn't make sense to predict far longer, but for example, for arrivals, we make predictions from the next hour to about 1 month in length. People in the emergency department, many of them, most of them actually are sent home or die. There's not much sense in predicting these kind of things, but it is sort of important to predict another way out, which is you are referred, you are discharged to another center. For example, because you want to have a hospital, an ambulance ready for sending these people there fast. Okay. The complicated part is because a part of these people need to be hospitalized, so they require a bed up because they are typically up in the wards in the cardiology department or in the traumatology department, or in the pediatrics department, or in the mental health department, etc. Okay, where the beds are finite and you need to control them. Some of these people actually need surgery before going to the bed, before going to the ward, okay? And the operating room slots are also very finite and very critical resource and very scarce often, okay? And here's where most of the complication goes, because about the other half of the people arrive to the hospital via programmed schedules, typically for surgery, not necessarily, and through a waiting list. That's this mechanism is really very different in different countries. I tell you that in Spain, the issue of waiting times before you get a surgery is actually a very hot political issue. It gets debated in parliaments, because really, if people take too long for certain surgeries, they actually gonna die or going to be very complicated, okay? So people that are included in the waiting lists need to have some pre-op tests, and that's also one of the bottlenecks. Eventually they get to be operated, okay? And maybe they get to need a bed, okay? The clash between programmed and urgent occupancy of beds and the operating rooms is really one of the most critical problems that the hospitals faced. If you allocate too many resources to just in case urgent people arrive, the waiting lists get longer. If you want to clear up the waiting list, you allocate fewer resources for the emergency department, and then if too many people arrive unexpectedly, then you're in big trouble. What do you need to do then? In order of pain, you have to call the wards and ask, can you actually speed up discharges? Please, I'm going to need 10 beds this weekend and I don't have them. You don't have them, okay? Maybe you can send some people home. Maybe you can, maybe you cannot. You can open up new beds, which means, some wards are closed and you can open beds. And that means also hiring new people to help with those beds. So that's cost. Worst case, you can actually unschedule scheduled surgeries. And that is really very painful. Actually, the healthcare systems penalize that a lot. Imagine I have to be operated tomorrow. I have already taken a day off from work or whatever, and suddenly they call me, sorry, your surgery is canceled. We'll schedule you for later sometime. That's really very psychologically damaging and a big problem for the people and their families. Okay, resources. You've seen there are some flows predicted, some resources used. The resources that are everywhere, and the most critical ones are human resources, which to some extent you can plan for, but there is the problem of absenteeism, which is huge in healthcare system. So we have a predictor for absenteeism, and therefore trying to let people know if they have to hire reinforcement for that. There's many papers trying to make predictors for all the things in red here. There's tens of them, hundreds of them. Many of them stop at the point where, okay, and we tried this and we got an area under the curve of 0.8. That's good. Now somebody should do something about it. What we try to do in Amalfi is actually let's go beyond that. Let's put that in production and not stop at the area under the curve, okay? And also, I think, I don't know that many people that have done this, is the fact that you can see everything that's happening in the hospital, that everybody can see my problems in my department, but somebody else's department as well, encourages a sense of collaboration and trying to solve the problems together rather than everybody trying to collect the most resources for me because this other guy is also asking all the time for more for my nurses and for my operating rooms, and I need those, okay? So that's it. Okay, couple of screenshots, why not? These are the weekly influx. You see that obvious every 6 hours. You see there's a daily pattern that's clear. This is probably like a pretty normal week. However, if you see the one below, the hospitalization requests, you may see that a couple of days at the end of the week are rather easy, but there is an unusual peak at the end. So maybe it's time that if I'm, say, the head of the emergency department person, maybe I want to start calling the wards to make sure that I'm going to have those beds. Maybe I look at how many people I'm going to have available. Maybe I want to start talking to human resources to see if I can have a reinforcement. And actually, one of the points I want to make in my talk is, okay, people at healthcare systems work because they want to have happier patients, healthier patients, because they want to save the system money, but we are all humans, so everybody wants to make their lives easier. So by having things like this, people can work more relaxedly, and if you are a manager, but also you can make your people work more relaxedly, the ones that are close to the patient. A couple of stories. The medical director of a hospital was telling us, okay, my shift starts every day at 8 a.m. I was going to work every day at 7 p.m. because I needed 1 hour just to start looking around how everything was and whether this looked like it's going to be an easy day or a complicated day. Now I can go to work at 10 before 8, and in 10 minutes I know what the situation is. I can maybe talk to my people and prepare the day. Another example, and we all have our egos, the head of an emergency department. She was using already the tool to see how everything was going. And this is a story that makes me very proud because it marks a moment in which the person starts trusting the tool. Easter vacation was arriving. The prediction of influx was saying there will be more activity than usual during the holidays in Easter, okay? And there will be an extra number of people that will be absent. I don't know who, but you'll have some people missing. So she thought about it and she decided to put her hand in her pocket to hire reinforcement for those days. We were lucky. Our predictions were correct. There was indeed a need for that people because there was the activity. And the person really got caught on the use of the tool when their people came to her and said, wow, thank God that you actually hired these extra people. Otherwise, it would have been a nightmare here. Yeah? These kind of things matter when people need to use tools. Okay, a little bit about the technicality. So it looks at what you're doing in what we're doing in these tools is basically time series prediction. It is. The data is not time series. It's data about a specific patients and the people that arrive or about employees. Okay. Drift is the problem, really. So in some of the predictions, really, it's a Poisson distribution, and you cannot do much about the variance. It's how many people are going to come from the territory that I work with. Well, that's a Poisson, so some people are going to arrive. In some cases, that's all you can do. Influx, well, that's what's going to happen. But in some others, for short term, you have information about the people that you're going to have. How many people I'm going to hospitalize in the next 6 hours? Many of the people that you're going to hospitalize are already in the ER, and you have information about them. So what we do then is you actually make prediction for each individual people that you have there. You assign a probability of hospitalization in the next 6 hours, okay? You add the probabilities, and if your predictors are well calibrated, that should give you a good estimate of how many of the people that you already have are going to come, plus others that will come. For the absenteeism prediction, how many people are going to show up tomorrow? Well, it's going to be mostly the same people that showed up today, okay? So there's ways of going beyond the pure Poisson, okay? The customer metrics are very important. People don't care about you predicting very well how many people are going to arrive at 3 a.m., which is going to be 1 or 2 people. They care about how many people are going to arrive in the peak hour at 12 or 1, which is where you're going to have trouble, okay? So you need to wait very much and design the metrics for your predictors carefully. Our workhorse in terms of predictions are gradient boosted trees, but we ensemble them in many ways. Here's, I think, what is important. People ask me, what is your algorithm? I tell them, I don't know. I don't know what the algorithm is today. We are retraining all the time. I don't even know which features are being used today. We have a large pool of features, and what we do is we train and retrain because the useful features change over time. When I tell you that drift is the problem, it really is. You have a great classifier, but then the hospital changes protocols and decides to treat some kind of people different with no notice. There's no way you can predict that. So what you need to look is, you need to balance the history of the activity with what has been happening recently, and that was actually my research in my previous life, okay? People ask me what kind of variables do we use. It's mostly activity and holidays. We are ready to add other variables, like for example, weather, it's something that they ask, or the soccer matches or the Olympics. But is it really useful? We tried, and for an urban hospital, for example, the result of adding weather was error 7% went down to error 6.5%, okay? And that creates dependence on some external web or whatever that gives you the weather. It was important, for example, in other hospitals, like we tried it on a hospital in the mountains in the Pyrenees, north of Barcelona, which is next to the ski tracks. Weather and actually, if the ski tracks are open or not, made a huge difference in the volume of people that you had and the kind of people that, and the kind of injuries that they had. When the ski tracks are open, it was all broken bones and twisted joints, and when they were closed, it was mostly the older people, elderly people living around there with this, okay. So I'm relatively proud of my algorithms. What I'm really proud of what we've done is this infrastructure to continuously train, retest, decide to which is the best algorithm now, which is the best set of features right now. Okay. And this relates to risks. I know it's important, and we impact not only the well-being of the managers, but also the well-being of the patients in, if you want, indirect ways. What I showed you is a news in France that basically concluded that every night spent of a stretcher in the emergency room increases mortality by 40%. That's a lot. And the other one is human factors affect errors, medication errors, or in general prescription errors. And you can bet my new owners, which are insurers, know perfectly that the moment the ratio between nurses and patients, for example, exceeds a certain threshold, the number of errors go up very, very fast, okay? So we impact on the patient thanks to reducing waiting times and reducing substaffing situations. Okay. A little bit about the analytical platform. I'm running out of time, but so I'll be fast here. In this other platform, what we want to match is, what we want to actually find is how my patients really are. They come to us in a way that determines the activity, and I label them with one disease. This person was treated for diabetes, okay? But the actual people come, I label them as diabetes, but I have to treat them taking into account that they also have kidney problems and heart problems and respiratory problems. Maybe they start having cognitive problems, okay, oops. And this is not well reflected by clinical guidelines, which are very much one disease, one clinical guideline, or things like the business intelligence tool, which are very much one-dimensional. So we want to use this tool to change protocols, understanding really how people are and what they need, and also focus the resources on the people that are at highest risk and need most resources. It's an exploratory, non-prescriptive tool. It has basically 4 algorithms of interest to KDD. One is patient clustering. Clustering looks like this. The 4 columns are the 4 clusters that were discovered on a particular population, like let's say people with diabetes or chronic heart failure. And the rows are the different diagnostics, because I told the clustering algorithm, use only the diagnostics to do this. There is an association explorer, which diagnostics come together, which, if you have a matrix of patients and diagnostics, can be seen as clustering columns, clustering diagnostics. There is a tool for population comparison. How do people with these set of diseases do compared to these other, the people with this other set of diseases, maybe, or how people in this city do with respect to people in this other city, so that I know that maybe I'm not treating people in this other city pretty well. And then another tool for flow analysis, which is mostly, it's not for hospitals, it's really for the people that plan the territory, that want to know where do people go and get treated, and is that the same where I expect them to go, so that maybe I can see that some areas are under provisioned in terms of resources, okay? It's a very generic tool. Actually, we have a problem selling this tool because it can do so many different things. My colleague says it's like a stem cell. It can specialize to a liver cell or a muscle cell or a neuron or whatever, but you need to show your potential customers that with this stem cell, they can basically adapt it to their problem. So just a few use cases. I will not go into any detail. For example, analysis of these DRGs, these groups of people for which I get paid by department. Real case, people with chronic heart failure were being sent both to the cardiology department and to the internal medicine department. And it turned out, if you look at the profiles in one and profiles in the other, that the protocols for assigning them to one or the other were not always best. There were some kinds of patients that should be swapped, because really the key point is in a heart problem, or really the key point is on all the comorbidities that they had. Another case, risk of complications. I told you in this minimum basic data set, you have a list of diagnostics. In the good versions of this data set, each diagnostic comes marked as present on arrival or not present on arrival. So did the patient arrive with these diagnostics, or is this something that appeared while the person was in the hospital, okay? That's usually complication, an infection, or some disorientation, or some sepsis, or some kind of shock, or some kind of problem induced by the surgery, etc. You can bet my new employers, let's say my new bosses, are super interested in that. And with this, we can see for one specific problem, like heart failure or childbirth or this or whatever, which are the profiles of patients that develop most complications in hospital, okay? And then you can adapt protocols specifically for this. Of course, it would be great if you had resources to treat everybody better, but you only have resources for doing an extra effort on 10% of the people or 20% of the people, okay? Length of stay analysis by looking at what kind of people stay longer than the government expects you to keep them in hospital. You can actually save hundreds of bed days with associated costs in a medium hospital. And this is something I'm really proud of. This is not for hospitals, this is really for home care. The more people get older, the more important it is to try to keep them at home for longer. And here, the issue is that people at home are treated by the healthcare system and by some kind of social work. You send people to you send social workers to elderly people's home to help with cooking, to help with taking their medication, maybe for taking them for a walk around the block now and then, etc. Okay. Incredibly, these two worlds in many places do not talk to each other, because they belong to different ministries with different budgets. I'm very proud of this project because for the first time, as far as I know, in Spain, we actually took data from both worlds and tried to mix them and indicate places for coordination. Okay, and that's about it. Okay, just for fun. As I said, this is a complicated tool. Most of these projects we did were actually kind of a consulting project. Okay, so we try to make the tool easier to use for most people. One way, this is for fun, this is a recent project, and you cannot talk at KDD these days without talking about large language models. We have added a layer for usability on top of the tool, whereby it's called Gepetto. This was the project code name. You can probably guess why. Where you can tell the tool, give me all the patients over this age that have arrived for birthdays during these dates and that have been diagnosed ever as diabetics. And well, you get a translation, you get the query to the database, and you get Gepetto tell you, that's at the bottom, what it understood from your description. Okay, good. So I'm over my time mostly. This is the platform that we have created. It's basically one layer for getting data from the patients, another layer for executing the algorithms, blah, blah, blah. This was initially done mostly for convenience for our technical team, but we are finding uses of this. So this is in fact an asset. For example, everything that you can do with the platform, you can do through the API of the customers, but there's another API for third parties. And we are exploiting this in two ways. We are beginning to contact other startups that want to solve problems that we don't address and want to save the hassle of doing everything that we've had about permissions and authentication and databases and blah, blah, blah. And the other one is we are making tests for integrating ourselves as algorithm providers to people that already have software running and customers in the hospitals. For example, business intelligence that provides very nice retrospective reports and very nice real-time information, but don't have prediction, so that we can provide prediction with the data and for the customers that they already have. Okay, from the lab to the hospital, some more software engineering aspects of that. We are a very small team for everything that we have done and that we needed to do, so we needed to organize ourselves very well. One decision that looked strange, but we adopted pretty early, is there are data scientists in our team, there are software engineers, and there's one person in systems and DevOps and site reliability and all these things. Everybody knows about everything. We blur the distinction about these roles because too many cases it happens that the data scientist creates a fantastic model using whatever, Jupyter Notebook or whatever, passes the model to engineering who doesn't understand about what this model does, and then it's eventually a disaster because it doesn't know how to maintain, how to change, etc. Okay, so we adopted some of the practices from extreme programming. One of them is pair programming. People work most of the time in pairs, so the pairs rotate very frequently. So on one given day, you may have the DevOps guy working on a predictor with the junior data scientist, and a senior data scientist working with the software engineering on refactoring some obscure part of the user interface. This way, everybody knows everything, and we try to avoid what's happened to us is some key person leaves, and then no matter how documented everything is, you have to throw away and redo everything that we've done. Tests before code, etc. Every test, every error in our code should happen only once. After that, there has to be a test so that it doesn't happen again. Every alert that comes from production, some server that once that goes down, the customer starts sending garbage data or some missing feature, etc., has to generate an alert that may go to our team or to the customer's team. And this is the hardest one to do. Once a task has been performed 3 times manually, automatize it. Yeah? This is a principle. As I say, there's always pressing issues. Okay? Mostly everything is in metadata. You want to change something specifically. Your customer wants to predict something specific, some kind of patient. You can do that through metadata, and that is key so that these non-core tasks can be outsourced to distributors or to partners or to even freelance people. Okay, as they say in my team, the technical team size should be O of 1. Okay, it should not be 5. For everything that we need to do, it should be more like 15 or 20 at the moment. But the point is that we need to automatize everything so that we have very little dependence on our number of customers. And that's all. Compared to other situations, we do believe that management problems are the easy way in for AI in health, something that you can use to solve real pressing issues right now with low deployment costs, avoiding the silo problem, avoiding many of the hairy ethical and regulatory concerns, and as I say, making adoption easier because you have an impact on people's lives, on the people that are going to push for having your solutions adopted. Thank you.